Hello everyone, this is the worksheet on the fourth section of chapter 14, which was on linear correlation coefficient. We are first going to answer some short questions on the concept of linear correlation coefficient, like what it is and what's its use and so on. And then we'll go into some simple problems to calculate the linear correlation coefficient using the defining formula and then the computing formula. So the first question says, what is one purpose of linear correlation coefficient? Now there are two purposes of the linear correlation coefficient. One of them is to measure the strength of the linear relationship between the two variables. So how strong X and Y are correlated, and the other one is to understand the direction of the relation between the two variables. That means if X increases, does Y also increase or does Y decrease? So let's try to write down the answers. For the first question, it says, what is one purpose of linear correlation coefficient? There are twofold purposes, but since they've asked for one, you can answer with one use. However, I'll just write two of them here. The first one, just a second. All right, the first one is to measure the strength of the linear relationship between the two variables. Linear relationship between the two variables. And the second one is to measure the direction of the relationship. All right. So let's underline the key words here: strength and direction. So direction means as X increases, so we have X and Y. As X increases, does Y also increase or does it decrease? So as X increases, Y could be decreasing. All right, so that's what direction tells us, about the values and the relationship of X and Y. Now number 2 says the linear coefficient is named by another name. What is it? So I'll just give you the name here. This is not a very important question, but the linear coefficient is known after the person who studied and came up with this concept, and his name was Pearson, and therefore the linear coefficient is also known as Pearson product moment correlation coefficient. Product moment correlation coefficient, really. So correlation coefficient. Now we did not mention about this in our lecture slides. I don't know if this is mentioned in the book or not. I don't remember, but this is another name by which people refer to the correlation coefficient, but most of the time it's just referred to as the correlation coefficient. Now question number 3 says the symbol that is used for the linear correlation coefficient is the small letter R. Right? So R squared is used for the coefficient of determination, whereas R is used for the correlation coefficient. A value of R close to plus minus 1 indicates that there is a strong linear relationship. So if the value of R is close to a positive 1 or close to a -1, that means it's a strong relationship between the two variables. A value of r close to blank indicates that there is either no linear relationship between the variables or a weak one. That means if the value of r is a 0, then there's no relationship between the two variables, right? Oops, I don't know, just a second. Let me fix this here. Okay, I'm back. So the next question says a value of r close to blank indicates that the regression equation is extremely useful in making predictions. So that's the same as number 4. It's just stating the same thing. A strong relation is being stated in a different way. All right, that x is extremely useful in making predictions. So that's plus minus 1. Right, so if we have an r value of close to a +1 or close to a -1, that means it has a strong linear relationship, which indicates that the equation is pretty useful or very useful in making predictions. Number 7, a value of r close to 0 indicates that the regression equation is either useless or not very useful in making predictions. If y tends to increase linearly as x increases, the variables are positively correlated. All right, it's positively correlated. That means as x increases, y also increases. Y increases. Number 9, if y tends to decrease linearly as x increases, the variables are negatively linearly correlated. So what they are saying is, if x increases, y decreases, then that means it's negatively correlated. If there is no linear relationship between x and y, the variables are not linearly related. All right. Number 11, the linear correlation coefficient of a set of data points is 0.846. Is the slope of the regression line positive or negative? Explain your answer. Now, we also talked during the lecture about the relationship between r and the slope, b sub 1 or beta sub 1. All right. So, and we said they are kind of linked, the two. Right, because just like the slope can be positive or negative, the r value can also be positive or negative. And if the slope is negative, that means the y values are decreasing, and the same is with the r value. If r is a negative value, the y values are decreasing. If r is a positive value, the y values are increasing, just as with the slope, just as when the slope is a positive value. So it's going to be the same thing. Is the slope of the regression line positive or negative over here? Yes, you can look at your r value and know that your slope is also going to be positive. All right, so we are going to say that since r, to explain our answer, we are going to say since r is a positive value, the slope is also going to be positive. All right. Determine the coefficient of determination. The coefficient of determination is r squared. If you're given r, right, if you're given r, then you can just square the r value to get the coefficient of determination. So if r equals 0.846, then r squared is 0.846 whole squared, all right, which will give us a value of 0.716. All right, so keep in mind, if you are given the r value, you can find the coefficient of determination by squaring the r, and you can come up with that value instead of going through the equation, working through the equation for r squared. However, if you're given r squared, it is not advised to take its square root and come up with a value of r, because you will not know whether r is a positive or a negative, because when you take the square root of something, it can be a positive value or a negative value. So even though the absolute value of r is going to be right, but r always comes with a positive sign or a negative sign or a 0, right? So if you take the square root of r squared, you will come up with an absolute value for r, but you won't know which sign to associate. Okay. Now for the next question, it says we have to find the r value using the defining formula. Okay. Now we're going to use the same example that we used before for the coefficient of determination, but here we are going to use the defining formula for r, which is 1 divided by n minus 1 times sigma x sub I minus x bar times y sub I minus y bar divided by s sub x and s sub y, which represents the standard deviation of x values and y values. And we also need to find the mean of the x and the y values as well. All right, so let's first start with finding the mean of the x values. So x bar is going to be sigma x over n. So n is 3. X sigma x, how much is sigma x? X sigma x is 4 plus 2, 6 plus 3, 9. So it's 9 divided by 3. So our x bar value is going to be 3, correct? Our y bar value is going to be 7 plus 3, 10 plus 5, 15. So sigma y is 15. So y bar is going to be sigma y divided by n, which is going to be 15 divided by 3, and therefore 5. All right. So x bar has a value of 3 and y bar has a value of 5. So now we can complete the next two columns. Just have to take the x value and from it subtract 3. So 2 minus 3 is negative 1, 4 minus 3 is positive 1, 3 minus 3 is 0. For the y minus y bar, take your individual y values and from it subtract 5. So 3 minus 5 is minus 2, 5 minus 5 is 0, 7 minus 5 is a positive 2. Now in the next column, which is the fifth column, multiply the previous two columns, x minus x bar column and y minus y bar column. So minus 1 times minus 2 is a positive 2. 1 times 0 is a 0. 0 times 2 is a 0. All right. And then you have to sum it up. All right. The sum of all these values is a 2, easy summation here. So sum of x minus x bar times y minus y bar is equal to 2, right? That's the sum. Now, for the last two columns, all you do is square the x minus x bar column, the third column values, and the values in the fourth column, and write them in the respective last two columns. So x minus x bar squared, so minus 1 whole squared is a positive 1, 1 squared is a positive 1, 0 squared is 0, and now sum them up, so you get the summation is a 2, and then for y minus y bar squared, sum up all the values in the fourth column. So we have 4, 0, and 4, and we should come up with a value of 8. All right. So these are the values we are going to use here. So this sigma x minus x bar whole squared equals 2, and sigma y minus y bar whole squared is a 8. Right. So first we have to find our s sub x and s sub y, the standard deviation values for x and y. All right, so let's do that. S sub x is square root over, now sigma x minus x bar squared we already found to be 2. So 2 divided by n minus 1, n is 3, correct? N equals 3. So 3 minus 1 is 2. Therefore, square root over 1, which is a 1. All right, that's s sub x. S sub y, again, this time use y minus y bar squared summation. So that's 8 divided by n minus 1 is again 2. So square root over 4, which is a positive 2. And finally, r is, just plug in these values here, I mean the variables, the values for the variables. So 1 divided by n minus 1 is a 2, so 1/2, and then sum of x minus x bar times y minus y bar, so which is this value here, this value which is a 2, so times 2, right? This is a multiplication, that's our numerator. And in the denominator, we just multiply 1 and 2, s sub x and s sub y. So it's 1 times 2. And when you do the calculation, we get 1 in the numerator and 2 in the denominator for an r value of 0.5. Right? So that's the value of r calculated. And then it says determine the linear correlation coefficient using the computing formula. So let's do that, but we'll have to change our table a little bit, and let me just bring this down a little here. All right, same problem, same values for x and y, but now we are just going to work through the computing formula. So let's look at the computing formula first. First we have is the first term in the numerator, we have sigma x times y. So we need an xy in the table, a column called x times y. And then sigma x, which we can obtain from the first column. All we need to do is sum up the x values. Sigma y is the summation of the y values. And then this is again the standard deviations of x and y. This is the formula for that, right? So let's start with it. Again, for the first one, just write your values 2, 3, 4, 5, and 3, 7, right? These are the values of x and y. For x times y, just multiply the two values. 2 times 3 is 6, 4 times 5 is 20, and 3 times 7, 21. And when you sum them up, that should give us a value of 47. All right. The sum of the x values, again, we already did that before. It's 9, and sigma y is 15. Now x squared value is squaring all the x values, 4, 16, and 9, which gives us a sigma x squared value of 29. And the y squared values would be 9, 25, and 47, which when summed up gives us 83. Right now, we have all the terms here. Excuse me. I need to erase and rewrite here because I have floating letters all over. So give me a few seconds. This was 9, 25, and 49 for a value of 83. Right? So let's plug in the values in the equation. So sigma xy is this 47. That comes first. Then minus sigma x is 9 multiplied by sigma y, which is 15, divided by n, which is a 3. And then in the bottom we have sigma x squared. So here, let's break it down. Sigma x squared is 2 minus sigma x whole squared is 9 squared, right? 9 squared divided by 3, right? And then multiplied by sigma y squared is 8. Oh, I'm sorry. What am I doing here? Just a second. Excuse me. I think this got erased. This is not 2. 16 plus 4, 20, 29. Okay, I'm sorry. Let's change this to 29. All right. So 29 minus 9 squared divided by 3, which should give us a value of 2. It should match what we found here, actually, using the defining formula. That's what I was wondering what happened there. Okay, so for sigma y squared, it's 83 minus sigma y whole squared is 15 squared divided by 3, which should give us 47 minus 135 divided by 3 in the numerator. 9 times 15 is 135. And in the bottom, we have square root over. Now, this should be 29 minus 27. 9 squared is 81. 81 divided by 3 is 27. 29 minus 27. Let me just write it down here. All right. This is gives us 27, this calculation. And 29 minus 27 is 2. All right. So the first box gives us a 2. And then for the next box, it's 83. So we have 15 squared divided by 3. So 15 squared is 225. 225 divided by 3 is 75, right? So 83 minus 75 is an 8. Okay, so we should get in the numerator a value of 2. Now this is 45. All right. So 2 divided by square root over 16. Therefore, R is 2 divided by 4, which is 1/2, which is 0.5. And that's exactly what we got. The 0.5 is what we got also using our defining formula here, right? Again.